Welcome back to our next session. Just want to offer a reminder to everyone, if you haven't done the scavenger hunt yet, we will do our drawing for our awesome prizes during lunch. I believe there is a Amazon Echo Dot, a DeWalt drill, and something else. But basically, there's just 5 items that you need to do, and then turn this in, and you can be qualified for the drawing. We're just going to wait one moment, and then I'll introduce Mike Holmes, who will kick off the panel. You probably want that. Or leave it at your top. Okay, perfect. All right. This next session is going to include 5 speakers, experts in their field addressing carbon solutions and opportunities for existing lignite power plants. Moderating the panel will be Mike Holmes. Mike is the Vice President of Research and Development for the Lignite Energy Council. Please give a warm welcome to Mike.
Thank you, sir. Well, thank you. We started out about a year ago talking about the diverse portfolio of R&D projects that we have in the Lignite Research Program. And then this spring, we covered the industry-driven roadmap we have for technology development. Some of the topics at the time were value-added opportunities like rare earth element extraction from coal-related feedstocks, further improving the already great job everyone does at the mines for reclamation, an NDSU-led study along with all the different mines. And then we talked about next generation power. So the panel today, we're looking at a big portion of the R&D portfolio is focused on carbon capture, utilization, and storage. Everything from the capture technologies to the compression and transport, to the utilization and storage in the geology side of things. And we have great opportunities in our region for using that CO2 as a commodity. So today's panel is focused on just that, how to bring together those learnings and look at the next impediments, things that can be further improved on carbon capture, utilization, and storage, and creating the opportunity to use that as a way to help lower the carbon footprint and enhance the commodity value of CO2 while doing it for our existing plants. So today, to do that, we have a panel that represents what's needed to make that happen commercially, and that's an integrated approach with a diverse group here. I'll introduce all the panelists first, and then we'll go through the 4 different speakers. First up will be Bill Sawyer, and he's the manager of Clean Energy Solutions for Minnesota Power/Elite, and he's responsible for the development of strategy, technology, and business initiatives to further the advancement and implementation of carbon solutions. So Bill will be our first speaker, and he will come up and give the big picture perspective from a power supplier. And then following Bill, we'll have Craig Bleth, and he'll continue that type of discussion, except then hone in a little bit more on an individual power plant from a perspective of more like Milton R. Young. And Craig Bleth is Minnkota Power's environmental manager, and he's responsible for environmental compliance and development of compliance solutions for the cooperative. And then after the 2 of them, then we have John Harju, and John brings a broad perspective of not only technology development, but also the oil and gas and geology side. So he can talk more to the geology and the opportunity to use CO2 in our region as a commodity, not only for existing oil, but also the tight oil for future use in the Bakken type applications. And John is the Vice President of Strategic Partnerships at the Energy and Environmental Research Center. He leads the efforts to build and grow dynamic working relationships with industry, government, research entities globally. And then following John, we have Tony Armpriester. And Tony is the Director of Engineering, Procurement, and Construction for the Carbon Capture Program at NRG. And he's responsible for supporting their various development initiatives. And Tony can then kind of put everything together and talk about what they did down at the Petronova project, the successful CCUS demonstration down there in Houston that started operation in January. And so that's a commercially driven one that then we can look at, all right, how do we take advantage of those learnings, decrease costs, make improvements for a second of a kind, apply it up in North Dakota with North Dakota Lignite. So with that said, we're going to kick it off with Bill Sawyer, and he'll give that overall perspective from a power supplier.
Thank you, Mike. Good morning, everyone. So I'm going to lead off our discussion today and talk about, as Mike said, from an industry perspective, what we mean when we talk about carbon solutions, why it's important to us, to my company at Elite, why it's important to everyone in this room, and why it's important to the state of North Dakota, and talk a little bit about how we're approaching finding carbon solutions. So first off, who is Elite? Elite is an integrated energy company based out of Duluth, Minnesota. And you see the logos on the top of this slide are the subsidiaries or the Elite companies that are involved in our carbon solutions initiative. So BNI Energy, you heard yesterday from Mr. Wade Basons, who's the president of BNI Energy. He was on the CEO panel yesterday. BNI Energy, Minnesota Power is our utility that takes energy off of the Young Station. And Elite Clean Energy is our clean energy development company. So those three Elite companies have been involved in carbon solutions finding, carbon solutions initiative for about the last 6 years on the projects that we're currently working on with our partners. So you see here a representation of the projects within our strategy of what we think is needed for a carbon solutions initiative and integrated solution for industry. On the far left, you see a representation of the need for a carbon solution for existing plants. And so how do we keep our existing coal facilities operating in a carbon-constrained world? Project Tundra is our project that we're working on with Minnkota, and Craig will get into more about that in detail when he talks following me. On the far right side of your slide, you see another pillar of our Carbon Solutions Initiative, which is finding a new technology that could be used for load additions for utilities or replacements for aging facilities. The project that we're working on there, the technology is called the alum cycle, and we're working on developing that with our partners Basin Electric and Dakota Gasification here in North Dakota. And in the middle, the third pillar, or the leg that's needed to support each of the projects on the outside of this diagram, is a solution for being able to utilize the carbon that's captured from these facilities. So either through enhanced oil recovery or being able to permanently store that CO2 through sequestration. And you see some of the partnerships and some of the projects that we're involved in there, the P-Core partnership and the Carbon Safe project, both projects being led by the UND-EERC. So why are we all here today? Why are we here? Coal is king. Coal is the #1 fuel used for electric generation in the world. You can see from the chart on the right-hand side of this slide that if we look at just China alone, China dwarfs the United States in coal utilization and coal consumption. There's a lot of coal in the world, and there's a lot of coal being used for electric generation. In the United States, coal has been the #1 fuel for electric generation in the United States until 2016. So coal is king until it's not. In 2016, it was the first year that natural gas surpassed coal as a fuel used for electric generation in this country. Now that's changed slightly in 17, and coal has overtaken natural gas again this year for electric generation, but you can see from this chart the projections of what the forecast is for continued utilization of coal in a carbon-constrained world. So, of course, this is very important to us, and the reason why we're seeking carbon solutions. What are our challenges, and what's the background of why we're looking for solutions and why we feel this important need to work on these types of projects? Commissioner Crocius this morning did a great job of covering some of these key industry challenges. Low-cost, reliable coal generation has been challenged in today's regulatory environment. A lot of pressure on coal recently. At the same time, you've got a large supply of natural gas coming in to the market, but natural gas in itself has the possibility of huge swings in pricing or variability in pricing. And then the third component, of course, is renewable generation. Renewable generation has been expanding, continue to be built not only in North Dakota but across the country. But as we know, renewable generation is not base load, it's variable, it's intermittent. So why are we worrying about keeping coal in the game? Coal is strategic to us in North Dakota and in this country, which means carbon solutions and keeping coal in the game are strategic to us in industry. Keeping coal in the game demonstrates truly an all of the above energy strategy and the need for that baseload energy to support the renewable and the natural gas resources that are out there, makes a balanced portfolio and a balanced utilization of our fuels in this country. It allows for the utilization of the most abundant fuel that we have in the United States, coal. It also allows for a continued platform for U.S. energy security and the newest word that we hear at a federal level, U.S. energy dominance. So the utilization of our coal resources in this country and the ability to utilize the CO2, the carbon that's captured in these types of projects for getting access to these unavailable oil resources and expanding our capability in oil production in the United States. Another reason for the strategic nature of these projects is that existing plant solutions help us to maintain the viability of our existing fleet without the possibility of stranded investment from shutting down these plants early on without carbon solutions. And it provides a solution for carbon management globally, so we can be a leader in the United States, and this technology can then be used outward in other countries, countries such as China and other countries that are using a lot of coal for their energy platform. So how much coal do we have? You heard this again this morning, or a figure close to this. Based on 2016 coal production in the United States, we have roughly 350-year supply of coal in this country. And if you look at just the borders of North Dakota and inside our border, that number is more like an 800-year supply for lignite utilization in North Dakota. Natural gas has a fairly good supply, but significantly less than coal. It's more like 86 years of supply of natural gas from recoverable reserves in this country. So what do we need? I used this word once already. We need an all of the above energy strategy. We need a platform that allows us to continue using coal, the nation's most abundant fuel, while being able to provide a solution for the ever-constrained carbon environment that we're in. We need an integrated solution that allows us to cover all those bases. And what does that look like for us? We see it in three components. Number one, we need the technology available to us at the power plant to be able to capture the CO2 from that power plant in a reliable and economic way. We need the link of those carbon sources to the areas where we would utilize that CO2, so the oil fields in western North Dakota, in this case for our projects here in North Dakota. And we need the ability to utilize that CO2, to have a sink for that CO2, and there's plenty of opportunities in North Dakota for that. So the three key components that you see on the screen there are what we call an integrated solution for carbon capture and utilization. I had three on the last slide. It's really four things that are needed to make these projects work. In addition to those three technical items from a development standpoint, you also need number 4 on this slide. You need dedicated utility partners, and you need strong state and federal support. And we have that here in North Dakota. North Dakota is really the place to do this type of project. North Dakota is rich in all of these key components to be able to build this integrated energy solution. 25 billion tons of recoverable lignite in North Dakota. Numerous lignite-fired power plants that are creating the CO2 that can be used for enhanced oil recovery or permanently stored in geologic formations here in North Dakota. And that CO2 could be used to produce an additional 250 million barrels of oil just from the conventional fields in North Dakota. And if we crack the utilization solution for CO2 in the Bakken, 4 billion barrels of additional oil from the Bakken system. North Dakota is the place to put forward these solutions. You heard that again this morning. It's a state of opportunity. It has the carbon availability, it has the reliability of the fuel on site. The fuel is right next to the power plant. You don't get any more secure from an energy perspective than having your fuel right next to you and available to you at all times. Pipelines, yeah, pipelines for natural gas are great, but what happens if there's a disturbance in the pipeline? You're not going to get your supply, you're not going to be able to run your power plant. Renewables, we all know renewables are intermittent. They're not always going to be there. Your coal is always there. That's your energy security. That's your dominance. So we have the coal facilities. We have the oil resources available to us in the western part of the state. That link is fairly close, as Commissioner Kroschus said this morning. We're 100 miles roughly from the coal circle to the circles for the oil fields. It is truly a state of opportunity for these types of projects. And lastly, we have the partners here in this state. We have the dedicated energy industry partners that are working on the projects that I mentioned here already this morning. We have the government partners, all of you in this room, Lignite Energy Council, State of North Dakota, our research partners in UND-EERC, and our federal partners at the Department of Energy. And we have the technology industry partners that are with us on further developing their technology for these applications. So really together, the important part of this partnership to make this type of project happen is partners that are willing to work together to create these carbon solutions, and we have that here in North Dakota. I'm going to stop there. I'm going to turn it over to Craig. He's going to talk in more detail about Project Tundra.
Well, thanks, Bill. Thanks for that excellent background on why we're doing what we're doing to evaluate carbon capture and carbon use opportunities. I'm glad to be here to provide some Minnkota perspective on the carbon issue. And as all of us in this room are aware, there's some really transformative times going on in the utility industry. From a power supply and market standpoint, which is ultimately what's really important, and also from an environmental standpoint. And we all know that there was an election last year that did provide some near-term breathing room in the environmental arena, but especially in regard to the Clean Power Plan. So that said, we know that the Clean Power Plan is going to be replaced, and in fact right now the industry trade groups and I'm sure environmental groups and all other groups are attempting to provide input into that process as we go forward. And we do expect that the Trump administration will have an alternative alternative to the Clean Power Plan proposed and potentially out as final before the administration is through. Now, whatever that rule has in it, we know that it's subject to being strengthened and changed by subsequent administrations. So the lesson really is, we believe carbon is something we're going to have to deal with in the future in varying degrees, and as we go forward in time, the expectation for reducing carbon is going to be more and more. So we look at carbon capture as being a potential way to allow a plant to not just simply run less and reduce carbon. We'd like to run these plants as we've always run them and be able to manage carbon in a different way. So in the case of the Clean Power Plan, the expectation would have been that these plants run less than half the time. So that was a pretty severe bullet that was dodged, and I would imagine that last year's fall conference, the tone was a lot different than it is at this year's fall conference. The important thing is we're taking those lessons, we're moving forward, and we do have to look at carbon capture as something we're going to have to deal with in the future. So a few words about Minnkota. Minnkota is a wholesale generating and transmission cooperative. We were formed in 1940. We had our 75th anniversary just a couple of years ago. We are comprised of 11 member-owner co-ops, and we also have what we call as a joint system with the Northern Municipal Power Agency, which is an association of 12 small cities that are located within our cooperative footprint. We serve about 143,000 customers, and we have just under 400 employees. About half of those are out at the plant in Center. Our largest co-op members are Cass Electric and Nodak Electric in North Dakota. And our headquarters has always been located in Grand Forks, North Dakota, and our early generating resources prior to the Young Station were also located in Grand Forks, North Dakota. Minnkota's generating resources include coal, hydro, wind, and some smaller diesel generators. Young 1 and Young 2 in Center are our largest resources. The Northern Municipal Power Agency owns 30% of Coyote Station, and that is part of our joint system, so is included in our generating resources. We have about 109 megawatts of allocated hydro and about 459 megawatts of wind. Our wind resources are located in eastern North Dakota, east central North Dakota, and these were brought into our system in the 2008-2009 timeframe. They were within our cooperative footprint and easy to bring into our system from a transmission standpoint. A more recent addition to our wind portfolio is the Oliver 3 wind farm, for which we get 100 megawatts, and that's just been within the last year that's been brought into our system. So back to our primary resources. Young 1 came online in 1970, and at 257 gross megawatts, that was about the size of the first cyclone units in North Dakota back in the late 60s, early 70s. It's 100% owned and operated by Minnkota, and its pollution control lineup includes an electrostatic precipitator and OFA and SNCR for NOx control, and it is a fully scrubbed unit in regard to SO2. Young 2 represents really the second generation of cyclone boilers in North Dakota at 477 megawatts, so it's almost twice as large as Unit 1. It's owned by Square Butte Electric Cooperative, which is an association of the same co-ops that form Minnkota. They have the same president and CEO, but a different board of directors, in order to keep the financing separate from Unit 1 and Unit 2. We had, since startup, power sales have gone to Minnkota and Minnesota Power. Presently, Minnkota takes 78% of the energy generated by Unit 2, and Minnesota Power takes 22%. By 2026, Minnkota will take 100% of the energy from Young 2. The plant is operated by Minnkota, and it has the same pollution control lineup as Unit 1. So, as we all know by now, hopefully, that Project Tundra is a potential carbon capture system on Unit 2 at the Young Station. And we're presently evaluating that with the help of EERC, the Department of Energy, the North Dakota Industrial Commission, and industry sponsors, Elite Clean Energy and Minnkota. When you think of what carbon capture looks like, I think it's really similar to, although it's an oversimplification, it's similar to an FGD scrubber at the back end of the plant. The maturity of SO2 technology at the present time, it's been demonstrated in actual practice. It works great, but it wasn't always that way. Back in the 70s, and we can speak from experience on this, back in the 70s when Young 2 came up with an FGD scrubber, we had a lot of difficulty with it relating to materials of construction, operability, reliability. But over time, those issues get resolved, and what we have today in the FGD world is very reliable equipment, very predictable, and easy to operate. So when we look at amine-based CO2 technology, that technology is actually, I think, 80 or 90 years old, so it's been around a long time. But it's not been around a long time on the back end of commercial scale coal-fired power plants. So there are two that we immediately think of. One is Boundary Dam in Saskatchewan, and one is Petronova. And Petronova would be considered the current state-of-the-art. And Tony will tell us a little bit more about that in a few moments. So what's really driving Project Tundra? Well, what's driving the project is the future need to control carbon. As shown on this slide, the expectation for reduction for the Clean Power Plan, the final Clean Power Plan, was 45% for North Dakota, and in the 40s for a lot of these coal-based states. That had increased drastically from what the draft rule had, which was 11%. And although the election placed this on hold, and the EPA will likely be reproposing a carbon legislation, it didn't seem like a good time to stop this evaluation. So even though Project Tundra was born of necessity under some stringent requirements, it still makes sense to continue to evaluate it. And like every utility, Minnkota continues to evaluate a lot of carbon reduction strategies. This is one of them. You also saw this slide in Bill's presentation. It's a good depiction of the overall carbon capture and reuse concept. The option for CO2 to sequestration, I'm going to talk just a little about, and that is really storage. So that provides a secondary offtake solution for when the oil field can't accept the CO2 being produced. And I think Mike mentioned earlier, EERC is expending some effort in across the spectrum, and one of those studies is called the Carbon Safe Project, and that is looking at potential storage opportunities and sites in both Oliver and Mercer County. And the Tundra project participants, along with many others, are participating in that effort. Project partners have been working closely with Mitsubishi Heavy Industries as a technology provider for the CO2 capture system. Mitsubishi does have the most recent and relevant and successful experience in applying their technology for carbon capture, which is the Petronova project. And one distinction that people should draw in their mind is that Kemper County is a different situation than Petronova. Kemper County, as we all know, has not been a successful project. Petronova has, and that is the analog that we're looking at to model. And I won't spend a lot of time on this. We all know we have a unique situation in North Dakota that very few states have. We have the combination of factors that could make a project like this successful, and the idea is that we really need to evaluate this and take advantage of a potential opportunity. So why here and why now? And Bill touched on it a little bit. We have substantial remaining useful lives in our units. At the Young Station, both Unit 1 and Unit 2 are projected to operate through 2042. Carbon capture would offer a potential option to simply running plants less to comply with future carbon regulation. And what would happen if carbon capture weren't a possibility would be that you would replace coal with low or no carbon emitting sources at substantially increased cost. Over the last 10 years or so, these plants have made pretty much across the board some significant investment in air pollution control equipment. And in some cases, that has even exceeded the cost of building the plant back in the 60s and 70s. So we need to be able to run them for their remaining useful lives to service the debt that's been accrued to comply with regulations like regional haze and the utility MATS rule. It's also important to note that just having a successful project like Petronova doesn't necessarily make the technology commercially available. There's much to be gained by successive projects that can take advantage of refinements to the technology and big things like saving potential cost on construction and optimizing design. So every time you go through the process, you learn a little more. The second, third, and eighth project that are built should get successively more economic to construct and operate. So going forward, we want to keep looking at the technical and economic feasibility of Project Tundra, and that's really where we're at. We're studying the economics, studying the technical feasibility. We know that we have issues to overcome in regard to North Dakota Lignite. Some of those issues have been experienced by Boundary Dam. We essentially have the same Fort Union lignite coal. So we are presently involved in a project with led by EERC with the project participants I mentioned earlier, which really does emphasize practical testing at the Young Station of an amine-based pilot scale system. And that's the direction we're presently heading, and that work will take place over the next year or so. And going forward, whether it's Project Tundra that gets built, we hope it's Project Tundra, but the work that we're doing now and that EERC is helping lead will really be a benefit to everybody in the industry in North Dakota. And, we do hope to be able to preserve all of the above energy strategy going forward, with Lignite a part of that. And that concludes my presentation. I'll turn it over to John.
Thanks, Craig. Well, thank you to Bill and Craig for giving the industry perspective, and I also want to thank all of the industry partners for the leadership and the vision and how engaged they are on tackling this challenge. And next we have John Harju, and he's got the perspective of not only technology development side, but also the geology side, as well as the commodity value of this CO2. So it's, again, a complete integrated picture. So next up, John Harju.
Thanks, Mike, and thanks, Bill, and thanks, Craig. And first thing I want to do is just say I'm up here talking on behalf of UND-EERC and the project team, but I work on a big team of people that has all kinds of other teams within it, and I know I've got 6 or 7 others from UND-EERC here, especially Jason Lom and John Kay and David Dunham and Nate Fiala and Ed Stedman and Tom Erickson. If you guys could just stand up and let everybody know who you are and where you are here, I'd really appreciate it. It's a team that gets these things done, not only externally, but internally at UND-EERC. So one of the things that I picked up on in Craig's presentation I thought was pretty interesting. That he said was born of necessity. Was the words that he used. And what I'm going to hope to show you is, okay, if we give birth from necessity on something like this, the way we build it is from opportunity. So I'm going to try to paint that picture, what the opportunity ultimately looks like. I mean, the broad vision we have is a sustainable solution for coal. And in my opinion, the way that works is we develop an economically viable solution that absolutely has an intrinsic component of it, enhanced oil recovery. So once we figure out how to economically and effectively capture CO2 at the local facility, we move it from those plants out into our oil fields, initially in our conventional fields, and I'll show you a little bit about what those look like, and then ultimately in our Bakken fields, and Bill painted a little bit of an idea of just how big those two opportunities are relative to one another, and I'll expand a little bit. And you saw this cartoon as well, just again showing how we integrate these things. So our P Corp partnership was something that Bill mentioned, and since 2003 we've been working on a regional carbon management strategy. And so the P Corp partnership includes all or part of 9 US states, 4 Canadian provinces. Somewhere in the neighborhood of about $130 million of total investment has went into this from the project partners, and the primary investor being the US Department of Energy. But it's built on managing carbon at commercial scale, and components of this are already in play today. So right now we have carbon dioxide going from north central Wyoming through a 220-mile pipeline up into Bell Creek, Montana, which is about 110 miles, give or take, from a really great group of oil fields in southwestern North Dakota. And we are actively watching that CO2 go to work into an oil field that at the time we implemented the project was in total producing a few hundred barrels of oil, and now it's producing about a day, a few hundred barrels of oil a day, and now we're producing about 5,000 barrels a day. And all told, by the time that project has come to its full fruition, it's going to produce on the order of 35 or 40 million barrels of incremental oil. So this is the kind of thing where, okay, now there's a whole bunch of potential revenue. So we've got lots and lots and lots of incremental oil that we can make out of these fields just because we can put that carbon dioxide to good use. There's lots of fields in North Dakota. We also have many, many geologic storage formations that in the event we ever run out of these EOR opportunities, we have abundant storage opportunities as well. You saw a graphic earlier. The red dots represent our big emission sources in the state, and our big emission sources tend to be coal-fired generation. But those green fields and the gray ones out here and the darker green ones all represent oil fields here in the western part of our state. So you see that great proximity. So in 2014, the EERC, in a legislatively commissioned study that was awarded to KLJ, it was the big transmission study. And part of that big transmission study looked at, how do we have to manage carbon? So it was a subcomponent. But our legislature looked at, future demands for electricity within the state, and as part of that, how might we manage carbon? So, in terms of that project, we looked at 86 North Dakota conventional oil fields. And the screening on this thing was, what are the fields that are reasonably likely to be available for CO2 EOR within the next 5 years? So that immediately pushed us toward these conventional fields, and I'll tell you a little bit about the difference shortly. But these are fields that are effectively ready for CO2 now. Ultimately, what you were looking at is somewhere between 50 and 300 million metric tons of CO2 could be utilized and stored in those fields. As a point of reference, the entire CO2 emissions profile for all of the plants here in North Dakota is about 30 million tons a year. So you're looking at, tens of years just in those fields that are really ready today. And somewhere between 300 and 600 million barrels of oil could be produced just from North Dakota fields, just using CO2 from these facilities. And that's just our conventional fields. And our conventional fields, what I'm showing you here are scanning electron microscope photographs of what the rocks look like, at a certain amount of magnification. So on the left side of your screen there is the reservoir that we're currently doing this EOR work in southeastern Montana. So it's a formation called the muddy sandstone. The light-colored materials really represent the grains. The dark areas on the slide represent the intergranular porosity. So that's where the oil resides, and you can see, wow, okay, there's quite a bit of porosity there, and you can visualize the idea of, okay, we're going to push some CO2 through those rocks. We're going to get some incremental oil. In the course of the first couple of phases of oil production in that field, they've produced about 30% of the oil in the field. And we think we're going to get another 15, 16, 17% of that oil that's in place in the reservoir through this tertiary process. On the right side of the screen are two SEM photographs of the Bakken. And this is, that's where the bulk of the oil in the state is, and the size of that Bakken opportunity for EOR absolutely dwarfs those numbers I was showing you earlier, a few 100 million barrels of incremental oil. We're talking a few billion barrels of incremental oil that we can get with CO2. I'm going to show you a little bit also about the urgency for that, because the recovery factors we have today in that Bakken system are so low. You see the obvious difference in terms of the lack of dark porosity in that Bakken system. And in fact, the top photograph is very consistent with what we call the seal on the reservoir on the left. So it is the formation that keeps the CO2 and the oil in that very formation that we're exploring in southeastern Montana. So today, here's what we know about the Bakken. The more we look, the bigger it gets. So what you're looking at there in terms of those green bubbles is the evolution of what we think exists in the Bakken system as a function of time. So we still don't really know exactly how much oil's even there. Now, in contrast, the little orange bubbles are how much of it we're getting. With the best technology we're utilizing today, we're getting a few percent of the oil in the system. So again, the more we look, the bigger the resource gets, and the harder we work at it, the better the technology gets. But still, all these years into it, we're getting 4, 5, 6, 7% of the oil in place, and CO2 can be a big-time game changer. So we have had the support of most of the oil companies operating in this basin. So all of the logos of those companies are down in the right-hand portion of this slide. The Journal of Petroleum Technology, the magazine cover there in the top right portion of the slide, is really the flagship periodical of the oil and gas industry. And our team at the EERC has actually had 2 covers of that thing in the last 2.5 years. Now, we had 0 covers of that thing up until the last 2.5 years. And right now, we understand that they're contemplating a 3rd cover for the work that we've been doing on this Bakken system. So it's very much pioneering work, but that also says it's very challenging work. So we've got a lot of work to do, which is why we need to focus on some of those near-term opportunities. We've learned that everything in that reservoir in southeastern Montana I talked to you about is basically not at play when we go into this Bakken system. So we've got a lot of work to do there, but it's very promising, and it's well supported by our partners. Bill touched on this. We're talking about billions of tons of CO2 that are needed, billions of barrels of oil that we're going to produce, and instead of 10 years, 15 years of all the CO2 from all the plants here in the state needed to realize that oil potential, we're talking about 100 years. We need billions of tons of CO2 to realize those billions of barrels of oil. Right now, we have one CO2 pipeline in the region. It runs from the Dakota Gasification Facility up to the Weyburn Field in Saskatchewan. Very well planned route. There's not a lot of additional capacity. We have pushed the notion of a handful of additional pipes that could be used here in the state. One of the reasons that you see that field in Saskatchewan operating successfully, so we know the kinds of reservoirs we have. These rocks are continuations of rocks that are present here in the state. But one of the things that you see in the province of Saskatchewan is the province tends to own all the minerals, whereas they're largely privately owned here in the state. We're a lot deeper. The trapping mechanisms are slightly different. And the other thing you see in the province of Saskatchewan is the Crown Corporation owns the power. So at the end of the day, the province kind of runs the coal mining. They kind of run the mineral asset in the oil fields. They run the power generation at one, and they've figured out how to make this work for them. Now, I think we can do the same thing here. And again, I'll really refer back to Craig's notion of born a necessity, but we need to build it on opportunity. And opportunity means everybody needs to be able to be profitable. This thing needs to work, not only for the companies that are putting it forward, but for the citizens of the state. So, again, I think North Dakota is ideally suited. We can make this thing happen. It's going to require some hard work, and EERC is very much blessed to have a lot of great partners and be a part of this solution. You saw this slide as well. Great partners make great projects. I think we've got a great project and a whole series of things that programmatically are going to move this technology forward. And with that, I'll turn it over to somebody that's already made this work. I think Mike will introduce him. Thank you.
Thanks, John. Thank you, John. And then for our wrap-up presentation, we have Tony Armpriester, and he's been part of the Petronova project we've all heard about. And so he's going to present on the successful CCUS work down there, how they take the lessons learned from that, and we can apply it again up north to North Dakota Lignite application. So welcome, Tony.
Thanks, Mike, and I thank the panel for all the good work you guys are doing here. I echo the commissioner's comments and what these guys alluded to, that there's not a better place to do another one of these projects than in North Dakota. So we really hope you guys are successful, and if there's help we can help you with along the way, we're willing to help. So some of you have been down to the project. This might be a little bit redundant for those who have been there, but for those that I haven't, I'll try and go quickly through this. I like to get to the Q&A portion. That way I can answer your questions versus just talking about what I think you want to hear about. We have the largest post-combustion carbon capture system on an existing coal plant down in Texas, just outside Houston. It's equivalent of 240 megawatts on the back of a 650 megawatt coal power plant. It's designed to capture 1.6 million tons per year. To date, since coming online on time and on budget at the end of last year, we've captured about 900,000 tons. It's a little bit short of our goal this year. We've had some disruptions, such as things like Hurricane Harvey and some other incidents, but for all intents and purposes, it's working as designed, and we're really proud of the facility. The CO2 is transported down an 81-mile pipeline to an oil field. To date, we've mobilized over 600,000 barrels of oil at the West Ranch oil field as a result of the CO2 EOR efforts, and I guess you can do the math on $50 oil, what that equates to. And as a result of the CO2 EOR process, we're essentially sequestering about 5,000 tons of CO2 per day. Here's a quick process flow diagram. This is what Craig was talking about that you guys are looking at Project Tundra. Diverting the flue gas that's otherwise emitted to the atmosphere, running it through a CCS amine process to scavenge out the CO2, transporting it down a pipeline, using CO2 EOR to mobilize oil that's otherwise unrecoverable, and then marketing that oil and selling it. The unique approach that we took with this project was, the oil revenues pay for the entire project. NRG is an independent power producer. We are not a utility. We do not pass our rates on to customers. We bid our power into competitive power markets, and if our power is not competitive, people go with an alternative choice. Electricity is kind of a unique industry that folks really don't care what the logo is. You just want your lights to come on, and you want it to come on at the lowest commodity price. So it's kind of a unique industry. We can't brand ourselves something unique and special. People pay for premium brands, but electricity is just a commodity. Obviously with no integration into the host unit, we have a standalone cogen power plant that runs this facility. We have no impact on our power price, the heat rate of the existing unit. It dispatches as it would normally dispatch, even without the carbon capture unit. Here's a picture of it near completion. It was physically complete. I think we were still going through startup. It's a pretty big unit, 240 megawatts of one 650 megawatt coal unit. So it's only 40% of the coal plant. And there's a lot of reasons we chose that size, which we can talk about later. Here's the process from afar. We've got 15-foot diameter FRP flue gas duct going in, bringing in the 650,000 standard cubic feet per minute of flue gas. Going through a quencher column, you have to pre-treat the gas. It's an exothermic reaction, so you have to cool the gas, and you also have to remove any trace elements of SO2 prior going into the absorption column. It's a chemical reaction. The flue gas bubbles up through an amine solvent. The solvent has an affinity for CO2. CO2 is absorbed into the solvent. The solvent-rich CO2 then is routed over to a distillation column. You can basically reverse the weak bond, capturing that CO2 by the application of heat. So through some process steam, you liberate the CO2, and then you recycle the amine product back into the absorber column. Once the CO2 is released, you've got to compress it. In order to transport it, you've got to compress it up to supercritical pressure, which is around 1,100, 1,200 psi. At our project, we're doing 1,900 psi, so we don't have to have any intermediate compression along our pipeline. Power from our cogen plant, locally sourced, is cheaper than doing retail power drops on a pipeline. And then we inject the CO2 into the pipeline right there at our plant. Over here, off to the side, again, retrofitting a brownfield site. There's usually not a lot of space to put these large emission control projects, and so we got creative. We sited the cogen off to the side, but it's a 75 megawatt GE 70A gas turbine with a heat recovery boiler that specifically provides the steam conditions that's necessary for the CCS. This is an illustration of the 81-mile pipeline that we built. We co-located it probably about 80% of the way with the existing utilities. The first 40 miles is co-located with a high-voltage power line, and then we jog over to another high-voltage power line. The commissioner talked this morning, pipeline projects are hard. In Texas, they're not that hard. The landowners are savvy. When you co-locate with existing utility corridors, the landowners have already been paid for that utility running through their property, so they know what they think it's worth, and they command a premium for that. And we did not have condemnation rights. We're a single carrier of CO2. In order to have condemnation, you've got to be a common carrier. And so therefore, we had a lot of landowner negotiations to get through, over 160 landowners. It's a 12-inch diameter pipe, 8 mainline valves, 1,900 psi at inlet, about 6-8 psi drop per mile. Get to the field about 1,350 psi, 1,400, and they go directly into the wellheads from there. Here's an illustration, enhanced oil recovery project. I'm going to get out beyond my skis. I work more in the CCS. John was going to correct me on anything I say wrong here, but the oil field's a stacked zone oil field. Field was a legacy field, discovered in 1938, but basically we're working from the bottom up and from the center out. So the drill campaign that you see on there is we're going to the lowest level sands first. We'll produce what's economic to produce in those sands and then work our way up. This oil field was 600 million barrel original oil in place. We're assuming that approximately 10% of that, or 16 million barrels, will be recoverable through this project. We also have a fair amount of monitoring and verification of the CO2. The oil field operator does that. It's a working commodity for the field. It's an expensive working commodity. They want to utilize that oil or that CO2 as effectively as possible, but we also have University of Texas Bureau of Economic Geology with some additional monitoring out in the field to make sure that the CO2 is staying where we intend it to stay. There are a fair amount of topside facilities that go into a project. In addition to the new 300 wells that we had to drill that were shown on the previous slide, or that will be drilled over the life of the project, you have new separation facilities. When the oil is produced, you've got a fair amount of water and CO2. You've got to separate all that out. Obviously, you reuse the CO2 for further mobilization, and then the water is actually re-injected into other sands in the formation for disposal. A point that I'd like to make about the work that we've done out in the oil field is this was a field that was done in 1938, and the way it was kind of matured over the life, folks have different ways of plugging and abandoning and, previous work that was done in the field. When you come in and do a CO2 EOR project, you completely overhaul that field, bring it up to modern standards, and basically put it in a better condition than it would otherwise have been left in if you hadn't done the project. So all the plugging and abandoning liabilities, we had to go through every well and make sure that the field was fit to receive the high pressure CO2. So just a thought. So not only are we producing and preserving domestic assets with our coal plants and legacy oil fields, but you're also refurbishing them at the same time. Here's the commercial structure that made it work. These guys have talked about partners are so key in all this. Central to our project, is the Petronova Parish Holdings entity that we set up. This entity owns the carbon capture system and the cogeneration unit. It's 50% owned by NRG, the company I work for, and 50% owned by JX Oil and Gas, which is the ExxonMobil of Japan. This is the entity that also took in the $190 million DOE grant, and we also have $250 million of Japanese financing in the project. Texas Coastal Ventures was set up to operate the oil field and the pipeline, and Petronova is 50% owner of that, and the original owner of the oil field, Hillcore Energy, retained 50% ownership in the pipeline and oil field. A lot of people ask how we were able to do this on time, on budget, outside of the natural luck that you hope for in major projects such as these. It's partners, everybody working in the same direction, sharing risks, having some skin in the game. The structure, we're not impacting the price of electricity. We're vertically integrated. We're not selling CO2. We tried to do that. I got a slide on that later on. It's still difficult at the price points we're talking about. The approach, we carved out a dedicated team. We worked really hard at, identifying opportunities to right-size the system, come up with a cogen approach, and locating the pipeline with co-located with existing utility corridors to minimize environmental impacts. The planning, we did multiple comprehensive feed studies. We didn't just come up with an idea and say, this is what we're doing. You've got to be agile. You've got to be able to react to change. You've got to be able to change the project. We started at a 60 megawatt project with a different technology provider, and we scaled it up 4 times and ended up with MHI at the end of the project. Contractors, getting qualified, capable, well financially backed contractors. Obviously, we did a lump sum turnkey contract with, performance guarantees, schedule guarantees. Getting folks to sign up for that, you pay a little bit of a premium, but getting those types of guarantees and commitments, especially on first of a kind, was key for us. Execution, we had a great team out there. We were all open, working in the same direction, collaborative. We stubbed our toe on something. We all got in a room and we didn't point fingers. We all said, how do we recover from this? What do we need to do? What do you need to make this happen? And it was a great team that we had out there, and not trying to bury things. One of the sayings we had on the project is, bad news is not like wine. It doesn't smell better with age. So, we need to get these out in the open and discuss, and let's figure out what we need to do. This is just a slide. I think the CCS industry is still progressing. Amine technologies continue to be refined. Membranes are nipping at their heels. There's some cell absorbents being studied out there. We think that there's a lot of development going on, which is fantastic. The utilization piece, obviously, of the tried and true EOR. They're looking at bulk materials. There's the X-Prize project out in Wyoming that Energy's a sponsor of, so looking for other ways to use CO2, and then obviously there's liquid fuels. The incentives continue to be refined. I mean, the high camp bill to expand and extend the 45Q tax credits is a fantastic program. It's getting bipartisan support. We think all of this is going to be a catalyst to future CO2 EOR projects, hopefully up here in North Dakota. There are some headwinds moving forward. We can't stick our head in the sand and say this is going to naturally happen. The cost is still very expensive to build these projects. There's not a lot of competition. I could probably name 5 or less than 5 commercially viable technologies that would back a commercial scale project with performance guarantees. Scale, a lot of the emerging technologies really haven't been demonstrated at scale. I will tell you, the Southern Company 25 megawatt Plant Berry project that we modeled our scale up off of was instrumental in promoting investment and getting our senior leadership to see that, hey, we can do this at 25 megawatts. Maybe 250 megawatts isn't that hard. A lot of the emerging technologies need to get some pilot scales out there. It's really hard for industry to go from an idea in a lab to commercial scale. Development, we just need to be able to react on our feet, change our approach. If an oil field won't talk to you, try and find another oil field. If you can't come up with a commercial structure of selling CO2, figure out a way to share the benefits of monetizing that CO2. There's a lot of different ways to get these projects done, and we just want folks to be open-minded. And then, the headwinds here, the reputation, I think Craig mentioned Kemper. That's, completely different technology. That's a brand new coal plant that's not preserving existing coal plants. But the reputation from some of the other CCPI projects, are a little bit negative right now, but we think we can turn that around, especially with the Petronova stuff. In time, it takes a long time to develop these projects. I worked on Petronova for 7 years. We filed a DOE grant in 2009, got awarded in 2010, and we just came online at the end of last year. So do I think it can be done quicker? Absolutely. We spent a lot of time up front planning and recalibrating and rejiggering the project along the way, but they do take a long time to get done. This is my final slide. We think there's a path to success here. The oil companies, they all deal in MCF. We deal in tons, but they deal in MCF. We think most oil companies are willing to pay about $2 an MCF. We've talked to a lot of them along the way in our project. That was kind of at $100 a barrel. If you look at today's oil price, we think that oil companies would prefer to pay closer to 50 cents MCF. $20 an MCF, by the way, is like $35 a ton. 50 cents is closer to 8 to 10. Here's where we're at. We're about $65 a ton. I mean, give or take. It's DOE studies have corroborated that, and the work we've done, it's close to $65 a ton. We believe that there are savings if this industry progresses. Obviously, there's going to be innovations. The FGD industry is a great reference industry. Costs come down, reliability comes up. So we believe that there's some opportunity there. The high camp bill, if we pass the expand and extend 45Q tax credits, I think there's going to be a lot more projects out there. We do need the pipeline infrastructure, so that's going to offset some of the benefits. You're going to have to build out that infrastructure, but it takes 4 or 5 years to do one of these projects from start to finish. So we think if all of this comes together, you'll start to see more projects coming online between the 2022 and 2023. I haven't circled back with Craig on his timeline yet, but that's what we think. Now, this may get pushed out a little bit depending on how things come together. If you had told me it was going to take me 7 years to work on Petronova, I would have said, yeah, I don't think so. We'll get it done quicker than that, but these projects tend to take that long. But that's my presentation. I'm happy. I think the panel's happy to answer any questions at this point. And we're proud of the project, and we're anxious to help you guys build one up here and preserve your coal and lignite industry.
Thank you. Please, before we start questions, join me in thanking all the presenters for the time and effort and the great presentations. So Luke asked me if I was going to be the game show host. If this is a game, now we're getting in the portion of Stump the Panel. So we have a microphone out there. I can't see very well, but please raise your hand and prepare your questions. And before you do, I get the privilege of asking the first question. And it's kind of an open-ended question, but we work a lot on technology, identifying the impediments, and then coming up with technology solutions. The other part of the picture is what else do we need other than just technology improvements, cost reductions? What can we do on the permitting side? The other ways to clear the path and make things happen, whether it be developing an infrastructure for transport of CO2 that people can share in. What are the other regulatory and permitting and other types of requirements we need to make something like this move forward?
Thanks, Mike.
Yep.
Check. Thanks, Mike. I'll start with an answer, and then others can jump in. Certainly, you mentioned some of the broader challenges that you would see in this type of project, or really any big project in the energy industry, but certainly this project, when you talk about needing to plan, site, and permit a pipeline from the center of North Dakota to the western part of the state to the oil fields, that's a big key for us in this project. And so being able to streamline, if you want to use that word, the process and the ability to do that and link up what would be not only the Young Station in the case of our Project Tundra, but potentially the other stations in the center of the state to all of the oil reservoirs in the western part of the state, and be able to utilize all of the CO2 that's currently generated is a big part of this integrated solution. So I think that is certainly one of the keys that we see going forward. So the state support, the federal support, also has an involvement component beyond just dollars. It's the ability to actually implement these projects, stay on time, build and execute the projects.
Okay, great.
Check. I would also say that from an environmental standpoint, those are always going to be hurdles you're going to have to jump. And in our case, we are looking at more of an integrated project, at least to start, as a project where Unit 2 could provide operating steam and megawatts to the project. And to the degree that those things would be optimized to maintain maximum uptime and availability, those could cause new source review issues. So those will be things that have to be evaluated.
I think the continued support of not only federal government in moving the technology, but also enabling viable solutions, extending authorities to the state, For instance, the state of North Dakota was recently announced as having primacy in regulating the subsurface introduction of CO2 and so on. So that's a big deal, and it's the first state that's seen that. The state in the last legislative session reduced what we call a unitization threshold from 60% to 55%. So in a good oil field, if you can get to a 55% working interest, you can ultimately pool those assets and operate it as a single field. That's really essential to doing one of these projects. So the state has actually been working with most of us for actually 15 years now in trying to get things lined up so that those regulatory challenges and those economic hurdles are things we can step past. Now, most recently in the last legislative session, some resources were made available to our team at EERC through the Commerce Department that are being heavily leveraged with the Energy Department and Minnkota and Elite and an oil field operator, the Lignite Council, North Dakota Petroleum Council, to do a comprehensive study on what is the full economic picture of doing something like this. So everything from mining coal to the conversions on the coal, to the capital infrastructure that gets installed, to the transportation infrastructure, to the CO2 recycling facilities, to that incremental oil, to those tax revenues on top of that oil. So actually building that entire economic picture of what this kind of technology means to the state. So I think as we go into the next legislative session, we're going to have a very comprehensive perspective on what this technology means to the state. Holistically, I think that's going to be really helpful for policymakers.
Yeah, that's important. Tony?
Yeah. Check. Yeah. So I get to go last. So I always got to come up with the last creative idea. But I actually would echo what Craig was saying about integration to a new unit. If there's permitting around new source review and trying to bring up all attributes of that plant to a modern standard, just to retrofit CCS. I think there's some opportunity there if it's an otherwise good working plant to help pave the way for CCS without maybe bringing it up to all modern standards, top to bottom. The other thing on the regulatory front is, the just leveling the playing field, like what the commissioner was talking about with the renewable subsidies, just not picking winners. I think maybe this 45Q and expand and extend would be a huge breakthrough and finally get coal part of the conversation again and, help level the playing field.
Okay, thanks. Questions out there? Dave has someone lined up?
Charlie.
All right.
Yeah, I like this subject, so Charlie Bollinger with Great River Energy. And while I have the mic, I might ask a question I've got a question for all of you, actually. Apologize to everyone else. I'm sure there are other questions, but from Bill, I was wondering if you could give a little update on the alum schedule. Where they're at, where do you see it going in the future, et cetera. I know you're working in Texas now, and from Craig, maybe I missed it, but what size would the Tundra project be? From Tony, I'm curious if he's landing on his parasitic, I know it's not parasitic load, you added a CT, but for a comparable 240 megawatt unit, are you landed on your regeneration and your total Petronova energy usage? I mean, the DOE, maybe paraphrase a little differently, DOE is looking for something between 15 and 20% of the total parasitic load. I'm wondering if you're landing on that target. I'm also curious if you thought about in your quench process some kind of byproduct production. Boundary Dam, for instance, is trying to anyway produce sulfuric acid on the front end with the SO2 that they're reducing. And John, I didn't really want to leave you out, but I'm trying to think of a question for you, but where's P-Corps headed next after Bell Creek, I guess? Have we got an opportunity to shove some CO2 in the ground at UC besides Bell Creek? Sorry about that, but that's what came out of my notes when I was listening to you.
Great. Bill?
All right, Charlie's got questions for all of us. Thank you, Charlie, for those questions. His question for me was, where are we at on the alum cycle schedule? So the new transformational technology that Elite is working on in combination with Basin Electric. You are correct, Charlie. There is a pilot plant being built in Houston, 25 megawatt plant, to prove out the core power cycle. So this is a brand new design of a power plant, and it operates at supercritical pressures and temperatures of 2,300 degrees Fahrenheit. So you're talking 5,000 psi, 2,300 degrees Fahrenheit, running through that system. So we have work ongoing with John's team at the EERC right now to look at metallurgy and corrosion impacts that you would see at those temperatures and pressures when running supercritical CO2 as your working fluid to run that turbine. So that work is ongoing right now, Charlie, while the pilot plant in Texas is under commissioning. So the pilot plant is expected to start up, call it Q1 of 2018. So just a few short months from now, that plant should start up and start providing us some data on the initial 25 megawatt design of that power block. And so moving forward from those two pieces of information, we'll be able to take information maybe about a year from now and look at that in total and say, are there some next steps for us that we need to continue to look at when building this new power generation cycle and the impacts that we would see in using lignite coal to fuel that power generation cycle. Craig?
Okay, that obviously was an important question for us right out of the gate, you know, and the most important thing for the project members was that we tried to represent an upscale in what was happening at Petronova, because that's most ultimately valuable to industry and to us. We don't have a limit on the top end of the CO2 that we can use. So at this time, in an amine-based system, you're still somewhat limited in the size of a single train. So what we're looking at now is somewhere in the range of 65% of the flue gas from the unit to 95%. And there is an elbow somewhere in there that to which you have to have not the front end of the system, the quencher and the absorber, but in the back end you would probably have to have multiple regenerators. So the economics, overall economics of the entire project would dictate, you know, where the sweet spot is, but it is important to scale up the project in a meaningful way from what's at Petronova, and the top end would be as dictated by economics.
All right, I think I had a two-part question, Charlie. If I get these wrong or don't answer your questions, continue to ask more. But I think the first part was around the energy consumption. We have that GE 75 megawatt turbine, approximately anywhere between 35 and 40 megawatts powers the entire system. The excess power is just basically deployed at grid at prevailing market prices. You know, if you look at the capture system, we have a 27,000 horsepower CO2 compressor, which you do simple math, that's 20 megawatts of the 35 or so. So it's really in the transport, it's not in the capture. A lot of capture technologies will exclude that in their energy calculations, by the way. And that's how they're more competitive than others. But the steam, it's process steam. I mean, you can do a conversion to a megawatt equivalent. I haven't done that recently. But it's pretty low grade steam. It's not, you know, high pressure, high temperature steam. So if that doesn't answer your question, I can get back to you on what the steam equivalent is. But that's on the power piece. As for the SO2, I think Boundary Dam has two amine scrubbers, one for their SO2 step and one for their CO2 step. And we have an FGD, we have a 1982 vintage FGD that's 82% efficient upstream of the CCS. So we just have a polishing scrubber, sodium hydroxide polishing scrubber to get the SO2 down to the ppm limits that are allowable into the absorber column. So there's not a whole lot of use for our little polishing step for that SO2 that we've been able to find. Hopefully that answers Charlie's questions.
Yep, that sounds good.
Well, Charlie, you asked where we're going next with the P-Corps program. We've got our annual membership meeting coming up in about 3 weeks. And for those of you who are members, we sure hope to see you there. For those of you who are not, there's a shallow plug. It's an opportunity to get on board in time for that membership meeting. But one thing I'm really excited about is a challenge. I serve on the National Petroleum Council, and last week in Washington, we were given a challenge by the Secretary of Energy, which is to build out the business case for how our nation's oil and gas industry can make CCUS a reality at commercial scale across the country. That's a challenge from our sitting Secretary of Energy. I think P-Corps will be very well aligned with the Secretary's wishes. I expect that we will have substantial DOE representation at the annual meeting, as well as some folks from the staff at the NPC and some companies that have not traditionally worked with us through P-Corps. So that's my thinking.
Okay.
Mike, this is Mike Jones, recently retired. And first of all, I want to say thank you to the group for an excellent discussion here. I've got a couple of questions I'll start with, and one for you, Tony. I know when the initial program was put together for Petronova, you were looking at a 90% capture. And I want to know if you achieved that or if you've gone beyond that. And a second part, if you were to do a second one, would you look for 90% today again, or would there be a better sweet spot? And then the second part of that would be for you, Craig, or Bill. With Project Tundra, have you made a decision what sort of capture you want to shoot for? And is that based on a sweet spot that you've identified?
Yeah, so to answer the 90% capture piece, the DOE FOA that we applied for stipulated 90% capture. Nobody can really get to the bottom of why 90%. In our due diligence, we've decided that the amine process, the natural process, does capture 90%. In fact, we're seeing a little bit better than that. I think we've seen upwards of 95%. But that whole stipulation on 90% for other technologies really needs to be evaluated. There may be other competitive technologies out there that can capture 60% at much more better economics than maybe an amine process. But the amine process itself, that's how it works. It's that efficient. And so therefore, it kind of meets the merit, but you would hate to box out other technologies that might otherwise be competitive at a lower capture rate.
Mike, I would say that, as we communicate the project early on, we set forth the goals of increasing the percentage of the unit over Petronova that we could potentially take out. But at this point in the project, we are really in the early feasibility stage, and a lot of the actual design and sensitivity analysis over size is going to have to take place when we get more into the pre-feed stage of the project, and those determinations would be made. Bill?
Sure, I'll just add to that, Craig. So there's two different percentages that we're talking about in these projects. It's how much of the flue gas stream do you divert into your carbon capture system, and then how much of the CO2 do you capture from that portion of the flue gas stream. So the numbers that Craig talked about earlier, 65% to 95%, that's the total flue gas stream at Young Unit 2. So we're going to look in that range, somewhere between 65% and 95% of the flue gas stream, to send that to the carbon capture system. And then the amount of CO2 that we would hope to capture in that system would be very similar to what Tony had mentioned in the experience at Petra Nova. So it would be targeting that 90% number because that is what the technology is capable of.
Yeah.
John Simmons with Carbon Tech Energy. You mentioned the 45Q tax credits. I understand that they're currently proposed at $35 a ton for CO2. Is there some indication where that stands in the Congress now, number one? Number two, Petra Nova, would you be able to take advantage of these tax credits if they pass?
I'm not a regulator. I don't know where that stands. I know there's been some bipartisan momentum. I don't know if somebody else has a perspective on 45Q and where that's at and moving forward. Please jump in. And I would hope Petra Nova can at some point apply for those tax credits if they do indeed get pushed through. That would be the intent.
I'll ask John maybe to give us a summary of where we stand with 45Q at the federal level.
Yeah, my understanding is the bill has been introduced and that there is a companion bill in the House that Congressman Kramer has co-sponsored, sort of known as the Conway bill from Texas. And concurrent with all of that, there's been a bill, I don't know that it's been introduced yet, but offered by Senator Hoeven that would provide some regulatory clarity on how one actually was able to document the storage that would allow utilization of those accumulated credits. So there's sort of three pieces, the House and Senate companions on the piece itself, which again, they're introduced, but I don't know exactly where in the committee schedules and floor voting they are. And then again, Senator Hoeven's companion, or not necessarily companion, but separate piece of legislation that would clarify.
So for those not familiar with what we're talking about when we say 45Q federal tax credit, it would be a credit for every ton of CO2 that's used for either enhanced oil recovery or that's permanently stored, sequestered underground. So that's the range of what we're talking about here. And then certainly there's a length of time that those credits would be available to a project, and there's a dollar amount associated with those credits for each of those scenarios.
Mike, one more. This is Mike Jones again, and this would be for Tony. I know in North Dakota we have legislation that after 10 years the state takes responsibility for the long-term liability of the storage of the CO2. Is there a similar legislation that's gone through in Texas that allows for that sort of a liability cap for you as a entity?
So I don't know what the Texas law is, but CO2 case law has been fully vetted in Texas. They've been doing CO2 EOR in the Permian Basin since the early 70s. That's why it's such a mature technology. I do not 100% know the long-term liability, who retains that responsibility, but all that's proven in case law. And I'm sorry, colleagues of mine would certainly know the answer to that. I can't attest to that, but I would think that North Dakota needs to build a robust CO2 EOR case law around all those sorts of things to help promote these technologies and reduce risks and concerns about that.
Okay, we have time for one last quick question. I don't see any more out there, so I'm going to hit them up with one last quick one. I presented at the Minnesota Municipal Utility Association, and I got this question, and it relates to regional differences. And there's a perception out there that, the questions come on storage permanence. They come on, the question of, places that have less stable geology, and someone injects water and sees seismic activity. So my question is for any of you, but I'm sure John's on the hot seat, on the regional difference and how we answer that question when they ask about CO2 injection causing storage permanence or fault concerns in our region?
Well, there's unique geologic characteristics that are associated with places where you do see induced seismicity, and we don't have those in North Dakota. So every day we are injecting on the order of about 1.5 million barrels of water into the Cretaceous sands in the Williston Basin every day. Today, no induced seismicity. That's the best analog that I can give you.
Perfect.
This is one of the most seismically stable places on the planet. We don't have earthquakes, and we're not going to have earthquakes because of this.
I need to bring you with on my next presentation, Sawyer.
Well, and just to add to that, there's some confusion. Folks think that CO2 into a reservoir is like fracking. It's the last thing you want to do in a reservoir. You want to keep the integrity of the reservoir and get to the miscibility pressures necessary. We're not fracking anything with CO2. That might be a technology down the road, but a lot of induced seismicity is around the fracking conversation, and CO2 that's not really what we're trying to do here.
Okay. As we wrap up, I just want to again thank everyone, but mention that they're each representing, as John mentioned, he's representing a bigger group, and each of these are. And so, in addition, they're representing North Dakota industry as a whole. And again, I can't say enough about the strong team effort, and that's what it takes for a challenge like CCUS. So with that, we're going to wrap up and start the networking, but please join me again one last time in thanking the panel.